Have you ever seen an internet meme that looks a little bit like this? Obviously, anti GMO proponents are trying to tell you that GMOs are horrible and will give you brain tumors, drought tomatoes, snail broccoli, and premature death. It's pretty scary, isn't it? How could people get away with putting such horrible things out there for us to eat? And they're everywhere. We're all going to die because of GMOs and Monsanto. No, we're not. This is called fear-mongering, and it's aimed to hit you at your basic need to be safe. Notice, there's no scientific study references. Notice, there's no actual data to back up their claims. There's a reason for this. There isn't any. I've been involved in science for the better part of 30 years, and in one way or another, I've gotten interested in the whole GMO organic schism for a number of years. I've gotten into a number of debates with several anti-GMO people, a lot of them who are friends of mine, and I decided I really need to look at the scientific studies and the facts closely. The best way, of course, is to either go to a peer-reviewed publication like Scientific American or use Google Scholar to look at the actual studies. The whole GMO organic debate has been picking up steam for a number of years and is reaching a fevered pitch right now. We have so many products that are marked non-GMO or GMO-free that it's staggering. Not to mention it's expensive because all this has to be verified in some way. But is it really worth it? Is organic really better? Does the label actually tell us anything worthwhile? It certainly is more costly, but is it worth spending money on? Most of us don't have a lot of money to burn on fads, so it's important to know the facts on this, especially if it's going to cost us money that we could be using elsewhere, like paying for bills or paying for tuition, because these things are not going to pay for themselves. Trust me, I wish they would. Today I want to educate you on GMOs, what they really are, and why we should not be afraid of them. The scientific consensus on this is very clear. GMOs are more stringently tested than organics, and they have shown to be no less nutritious and no more dangerous than organics. I put organics in quotes because nothing you eat, quite literally nothing, unless you've eaten venison, quail, or another wild animal, is not a GMO. Any grass-fed organic meat that you eat comes from a genetically modified animal that does not exist in the wild and could not. All the organic vegetables you eat are also genetically modified. So, just what is a GMO? Is it really different from an organic product? No, it's really not. A genetically modified product, a genetically modified organism, a GMO, is something that's had its genetics modified. And we've been doing that for over 10,000 years. The earliest example of biotechnology is the domestication of plants and animals. Domestication began about 10,000 years ago when our ancestors started keeping plants as a reliable food source. Rice, barley, and wheat were among the first domesticated plants. Wild animals were tamed to provide milk or meat or to help with plowing or guarding of the farm. The dog, sheep, and goat were among the first animals that were domesticated. Corn is a dramatic example of a plant that has been enhanced by selective breeding to become a better food source. The early teosinte plant from about 5000 BC had small cobs and few kernels, but by 1500 AD, the corn cob was more 5 times the size of what it had been previously and packed full of sweet, juicy kernels. Teosinte is an ancient grain thought to be selectively bred into maize between 6,000 and 10,000 years ago. It has few kernels and they are enclosed in a very hard casing. And it's not just the food we eat. GMOs have been advancing medicine, including one of the most commonly used medicines today. About 6000 BC, the Chinese were using moldy soybean curd, ew, to treat boils. Similarly, Ukrainian peasants were using moldy cheese to treat infected wounds. The molds release a natural antibiotic that killed bacteria and prevented the spread of infection. Despite all these natural treatments, it wasn't until 1928 that Alexander Fleming first extracted penicillin, the first antibiotic, from mold. How's that? As you can see, there isn't anything natural about anything we eat. Everything has been genetically modified through crossbreeding and selective breeding. You might as well give up the idea that you can go to a grocery store and get something really natural, because it's impossible. If you need some other examples, here we go! Okay, so now that we know that we don't actually eat anything that's natural, what is the real difference between organic and GMO? A lot of people think that GMOs use more pesticides in general, and that these pesticides are a lot more dangerous to us and the environment. But nothing can be further from the truth. Organics actually use more pesticides. Many GMOs are designed to be more resistant to insects and other environmental factors, such as drought and fungus, that can decrease or destroy plant yields. Traditional plants need more pesticides to fight off insects, and they also need more water. Plant pathologist Steve Savage has noted, copper-based fungicides are among the few options available to the organic grower for the controlling of fungal plant diseases. These are a high-rate use product that require frequent reapplications and which are also quite toxic to aquatic invertebrates. There are much more effective and far less toxic synthetic fungicide options without environmental issues, and which, unlike copper, break down into completely innocuous materials. Organic growers can't use these fungicides. Similarly, there are many environmentally benign synthetic insecticides and herbicides which cannot be used. So, not only are they better for the immediate environment, GMO crops create a smaller CO2 footprint and have higher yields. The Belgian Research Institute, BIB, released a report in September of 2016 attempting to quantify the impact of GMOs on the environment. Overall, the combination of GMO crops over the last 18 years has delivered substantial benefits for the environment. Insect-resistant crops have resulted in a 230 million kilogram decrease in the use of insecticides. Herbicide-tolerant crops have led to reductions in fuel use and CO2 emissions of 6.3 billion liters and 16.8 metric tons respectively by supporting no-till farming. Overall, GMO crops have produced an environmental benefit of 37%. GMOs also reduce soil erosion and increase soil health. The improved weed control provided by Roundup Ready varieties led to rapid environmental gains. By 2009, only 2 years after widespread adoption of GMO sugar beets, over 50,000 acres of land was conserved to some form of reduced or conservation tillage practices in Nebraska, Colorado, and Wyoming. That number is probably much higher now because that was, 8 years ago. Conservation tilling practices improve soil health, reduce soil erosion, and prevent soil moisture. Conservation tillage simply wasn't possible in the sugar beet before the introduction of Roundup Ready varieties because of the intense tillage was needed to obtain adequate weed control of the crop. Wow. GMO foods are not what they thought they were. They actually use less pesticides, Less dangerous pesticides require less require less water, create less erosion, promote better soil health, and give more food per acre than organic farms. But are they safe to eat? Because of Frankenfoods. Of course they are. GMOs are the most strictly regulated foods we have by far. They are also the most regularly tested foods that we have. Over 3,000 studies spanning 30 years have been done on the subject of animals that eat GMO plants, like cows, pigs, chickens, goats, and the sheep that we farm. This pretty much sums up how our farm animals are doing on GMO feed. Writing in the Journal of American Science, the most comprehensive study of GMOs in food ever conducted, University of California, Davis, Department of Animal Science Genetics, Allison Vine, oh boy, that's a great name right there, Einernam, and research assistant Amy E. Young reviewed 29 years of livestock productivity and health data from both before and after the introduction of genetically engineered animal feed. The field data represents that more than 100 billion animals covering a period before 1996, when animal feed was 100% non-GMO, and after its introduction, when it jumped to 90% or more GMO. The documentation includes the records of animals examined pre- and post-mortem, as ill cattle cannot be provided for meat. What did they find? The GM feed is safe and nutritiously equivalent to non-GMO feed. There was no indication of any unusual trends in the health of the animals since 1996, when GM crops were first harvested. Considering the size of the data set, it can be reasonably said in a debate over the impact of GE feed on animal health is closed. There is zero extraordinary impact. The study corresponded in review with other animal feeding data, some multi-generation as long as 2 years. But what about people? Okay, it's 29 years and it's 100 billion animals, and it's about as inclusive as you can possibly get for animals. But what about people? Because chemtrails, man! Chemtrails! Well, I hate to burst your bubble, but the evidence for human safety is just as large and conclusive. It's called the Trillion Meal Study. That's not million, that's not billion, that's trillion. It's a really big number. And if that's not enough data to convince you, then we're going to have some issues. The findings also comport with a long-term GMO field laboratory studies. The Genera database, found at Biology Fortified Online, lists more than 36 examples of multi-year studies. A recent review of 24 of these studies by the Snell, which is a global institution, found results do not suggest any health hazards, and, in general, there were no statistically significant differences within parameters observed. The authors also found no evidence to suggest any health effects on humans who eat these animals. No study has revealed any differences in the nutritional profile of animal products derived from GE-fed animals. Because DNA and protein are normal components of the diet that are digested, there are no detectable or reliably quantitative traces of GE components in milk, meat, and eggs following consumption of GE feed. In other words, the debate over the risk associated with GMO food is effectively over. And it doesn't end there. There are more than 3,000 studies and 280 global science organizations, including the World Health Organization, that recognize the safety of GMO crops and potential benefits. Ironically enough, most of them are not in the United States, but in Europe, where it's actually been banned. So, Who still thinks that GMOs are scary and have been tested enough? The facts are as follows. All foods that we eat are genetically modified over thousands of years, even supposedly organic food. Nothing we eat is in its natural state. GMO crops, however, show real advantages over organic crops. They are more resistant to drought, insects, and fungus. They need less pesticide. They need less dangerous pesticides, are better for the soil, and have significant higher crop yields. The science conclusively says they are just as safe as organic crops. And Dr. Stephen Novello writes, we now have a large set of data, both experimental and observational, showing that genetically modified feed is safe and nutritionally equivalent to non-GMO feed. There does not appear to be any health risk to animals, and even less likely that you could have any health risk on humans who those eat the animals. In order to maintain the proposition that GMOs are not adequately tested or that they are harmful or risky, you simply either have to highly cherry pick a few outliers of low scientific quality, or you simply have to deny science. And I'm out.